Hi, welcome back to geology. We're moving on with our rock cycle here. So we'll kind of wrap it all together when we've got a good basis or a good foundation of our three different types of rocks. So we've already started talking about igneous rocks, and we talked about intrusive and extrusive and the different types of colors that you can have with intermediate, felsic, and mafic. And kind of the different types of environments that these rocks can kind of be found in. Sedimentary rocks has a whole different set of characteristics that they can be found in as well. So we're going to go through those processes too. I have another box that we will be making observations with so that you can kind of get an idea, a fundamental idea of what some of these different rocks form in and how you can see them. So I do want you to take notes, so please make sure you get out a sheet of paper and get down anything that is underlined that I kind of talk about. So let's go ahead and get started. So we live in the world of sedimentary rocks. So as we go through, there might be times that I might say, hey, go outside and just grab one and let's take a look at it. We can tell a lot about the geologic history from sedimentary rocks. So you've probably heard me say before, I don't spend a whole lot of time with this in the rock cycle because when we get to the history of the Earth unit, we spend a great deal of time talking about sedimentary rocks because they normally hold fossils in them that can kind of give us an idea of what was going on, or they also are good indicators of what type of environment was there, because sedimentary rocks are normally a result of what type of weathering processes were there. So we can look at a sedimentary rock and be like, that was kind of eroded away due to a glacier. Or we can look at it and say this rock was formed in a ocean type environment. So Kentucky is a great example, especially the northern Kentucky, Cincinnati area. We were once a shallow seabed in the Ordovician era, where that we'll talk about it, but it was an era a long time ago before life became super large and complex. So when we look at the rocks around us, we can normally find rocks such that are called limestone, sandstone, and shale. These are all rocks that are formed normally in some type of shallow sea environment. So you've probably heard me joke before, it's like, hey, where's my oceanfront property? I want to be back to the Ordovician where I can walk outside and be close to the ocean, or a sandy beach, which is not the case anymore. So we would have been right smack in the middle of an ocean millions of years ago. So how do we know that is by looking at two processes in which sedimentary rocks are made of, which is compaction and cementation. And that's what this is right here. So compaction is a process in which sediments are squeezed and the size of the pore space is reduced. So let's go back to that beach type environment. So you're standing on the beach, you can clearly pick up sand and it's gonna just kind of fall right through your hands. Let's say that we dig down though about, let's say maybe 20 to 40 feet. That sand is going to be pushed and compacted more. So it might not fall right through your hands. It might be a lot of a different composition than what it is at the surface. And that's because those particles have been smushed together, smush. And then what happens over time is that some type of hydrous environment comes through and it's going to glue them together. So the water, kind of like with our geodes, is that we heated up the water, we dissolved the saturated material of the borax, we let it sit, and then we took away the water and the crystals formed. This is kind of the same idea with cementation, is that there's going to be some kind of hydrous material that's going to act as glue, and then that water is going to disappear, and then you're just left with a solid type of rock. And so if you think about, once again, our rocks here with our limestone and our sandstone and the shale, is that there was a lot of carbon in the water because there was a lot of life, and it compacted and glued those sediments together. So I have some good examples here. This would be an example of sandstone, which We can find normally down in the southern parts of Kentucky. We were kind of more in the middle of the ocean, whereas southern Kentucky, like where Eastern is and Paducah and stuff, they have much more of a sandstone type environment. So this is that, and if you'll get to see this one and feel it. It feels gritty. You can see that clearly it's not falling through my hands like sand would, so it's been compacted and then cemented together. Same thing with this one right here. This is one that you normally can't find in the Kentucky area. This is called coquina, and it is the same idea, is that it's shells that have been broken and weathered and tumbled together and then glued together. So compaction and cementation, those are the two things we're going to be looking at when we talk about sedimentary rocks. 3 different types of classifications: chemical, biochemical, and detrital. So I know I have a little bit more here. Chemical stands for inorganic, meaning that there was nothing living in the rock. So the sandstone would be a great example of a chemical inorganic rocks. Forms from minerals that were once dissolved in water. We will see our halite again. It's a bigger chunk than what we were looking at with our minerals. This is just rock salt. So if you think about like when the winter months, when we are pulling out some of the salt bags to help melt the ice, that is an example of what they're selling you, is a big chunk of rock salt. Our biochemical sedimentary rocks are formed from remains of living things. Coquina, great example of that, is that these shells were once part of a living structure. They no longer are clearly alive, and we've formed a sedimentary rock. Another great example, and we'll see this quite a bit, is our coal. Limestone is gray. So Kentucky, once again, is known for its coal type environments. That was formed after the Ordovician. So we've kind of gone through 2 geologic processes. We were once an ocean, and then we were a swampy bog type of environment. Now, clearly none of those are there. We've got more of a dense forest. So finally, our last one is detrital, which is just fragments of rocks that have been compacted and then glued together. So normally the sedimentary rocks have been broken down, maybe that are sitting at the bottom of a lake bed or a pond or a creek, and then they're compacted together. So maybe they're covered up with mud and then glued together. So you normally have like rock fragments that look like they're glued together. And so I have an example of this here too. I don't know if you'll be able to see the actual chunks that are kind of in there. I always think this looks like cement on like older homes, like where they have the big pebbles and then the cement over top of it kind of holding it together. So 3 different types of ways we can identify sedimentary rocks. This is angular, round, and well-rounded. So angular just means that the material has been tumbled ever so slightly, but you still have pretty sharp and jagged points to it. Rounded is that the material has been pushed further along and those angular parts kind of get broken off, so you get more rounded. And then finally are well-rounded. I'm gonna skip that slide here. And so features of sedimentary rocks, which I think are always really, really beautiful. So we'll kind of look at some of them. Some of them we can find around here in Kentucky, some we can't. The first one is stratification, which just means that we can see the layers. So think about like if you're looking at your notebook, or just like even just like something like this, is that you can see the layers in it. That's what stratification means, is that you can see the layers that have just been laid down over and over and over again. Sedimentary rocks such as limestone are a great example of that. Our next example would be cross bedding, which just means that the layers have been slanted, and we can see that there's been different types of striation. So this is a very arid environment, this picture right here, and we can see that the lines go this way and then they are shaped this way. So it's almost like a desert type environment. Is that the wind blew this way for a really long time, and those sediments got cemented and compacted together. And then the wind blew this way for a really long time and it got compacted and cemented together. Graded bedding just means that we have bigger elements that have settled at the bottom, and then it layers up to smaller elements. So it's like big, medium, and small as we're moving through. And then these 3 right here are pretty much exactly what it says. Ripple marks, think water, or a wind environment that just gets made into rocks. in our sedimentary rocks. Our mud cracks are just that the mud dried and then formed into a rock. And then our more interesting ones, I always feel, is our fossils and our coronations, which just means that we can see traces of living organic material that was once there. And this is a great example of dinosaur footprints or whatever it may have been. So sedimentary rocks have a lot more organic value to them, and that's what we're going to kind of focus in on, is like, how can we see those organic materials? So hopefully this was helpful. We'll take a look at our sedimentary rocks when you get into class.